Hi students, let us now see the next question. Question number 30, JE transfer material. Uh, this is a rod, a smooth rod, so the friction doesn't come in the picture, and it is the whole plane is vertical, so gravity is downwards. So right now the system is in equilibrium. Okay, so probably because of the weight, this has fallen down slightly, and then spring force has developed here, which is balancing the component of the spring forces upward is balancing the gravity force downward. So now what instead we should try to do, instead of worrying about what is happening in equilibrium and all, let's directly think about the moment you give it a certain displacement x. Okay, what would be the extra spring force? Okay, so this spring, like I explained in the previous problem, will come somewhere here. So you drop a perpendicular, if that is theta, this will be your 90 minus theta, right? So that is 90 minus theta. This is also 90 minus theta. So this extension will be x cos 90 minus theta, which is x sin theta. Okay, is it clear? Okay. So now the extension is x sin theta. So in this ring, there will be additional forces because of the additional displacement of the ring. In this direction, it will be kx sin theta, and here it will be kx sin theta, because theta is same in the two cases. So now displacement is in this direction. So we want force in this direction, right? Components of these two in this direction. So this angle is again 90 minus theta. So component of this force in this direction will be force cos 90 minus theta, which will again become force sin theta. Force already has one sin theta, so this will be kx sin square theta. And same will be this component also. So the net force which brings it back is 2kx sin square theta. So acceleration will be force by mass, so 2k sine square theta divided by mass into x. Again, the direction is opposite to displacement, so minus sign is understood. So your time period will be 2 pi divided by omega. Omega is root over reciprocal of this m by 2k sine square theta root. I can write here sine theta. Okay, so it matches with which option? 2 pi, which option C. Next problem is also based on spring. So in question number 14, a block of mass small m1 is executing simple harmonic motion of amplitude a on a smooth surface under the restoring force of a spring of spring constant k. So there is a spring whose spring constant is k. The block is performing simple harmonic motion on a smooth surface. Okay, whose mass is m1 and its amplitude is up to a in the problem. A block of mass m2 is gently placed on it at the instant it passes through its mean position. So let us say this is your mean position. So as it is oscillating, when it reaches here, another block is gently put here whose mass is m2. Assuming the two blocks move together, which means there should be some friction between this. One of the problem earlier we have solved that, okay? Similar to that. Assuming the two blocks move together, find the new period. Now if the two blocks move together, then omega will be what direct it is, right? Root over k by m, and if they move together, the mass of the system is m1 plus m2. So time period will be 2 pi by omega, which will be root of m1 plus m2 by k. So this is direct, right? So option A. 15 is extension of the same question. So this can be asked as comprehension in JEE Advanced. In the previous problem, what is the amplitude of the oscillation? So in this problem, what is the amplitude of the oscillation once you put m2 here? So why will the amplitude change? Okay, so think about this. When it is at mean position, this block m1, before putting this, will have a velocity which will be a omega, isn't it? Because that is the maximum velocity which a body performing SHM has at mean position. Now, when you are putting this here, gently they have to. So, if you consider both these two as system, at this position there is no force. So, you can apply law of conservation of momentum. So, m1 into v, which is a omega, is the momentum of this, and this has no momentum initially, must be equal to, now once you put these two, the mass will become m1 plus m2. Is it visible? Yes. And therefore, whatever velocity these two will start here onwards, that will become different. We will say v dash. So that will be the new maximum velocity. So v dash will be m1v by m1 plus m2. And this new maximum velocity I can write new amplitude times the new omega. The new omega is root over k by m1 plus m2. m1 by m1 plus m2. And what was the old maximum velocity v which this block had? It will be old amplitude into old omega. Old omega will be what? Root over k by m1. Okay. So now let us simplify. That is the last thing to do. So a dash will be, so you can see root k will cancel. So you cross multiply root m1 plus, okay, see directly you can do. So this is root m1 plus m2, here m1 plus m2, so here one root m1 by m2 will be left. Root of m1 plus m2. This is m1, this is root m1, so here one root m1 will be left. M2. So that will be the new amplitude of the oscillation once block of mass m2 is put there. Okay, so which option it is? Option A. Thank you.